He has received awards from the Indian Air Force Station for his best commendable work. He has received an appreciation letter for being a resource person from St. Joseph College as well as from Mother Teresa College. He attended more than 5 faculty development programs. He visited many international countries such as Germany, Malaysia, as well as Nepal. He is also authorized as a trainer in automotive technology, which was certified by Voss Reichert, Germany. Thank you. Now it's a time to hand over this session to our resource person. Welcome, sir. Sir.
The topic is IoT in industry automation technology, but I think we need to understand automation technology first, then only you'll understand IoT in industry automation. So let me start with funda, what is automation technology and other things. So that is what we are going to see for 1 hour. If time permits, with us, we have recently signed an MOU with the Daily Board. Set up a kind of automation technology lab in our I'm just going to correlate the automation technology concept with the case study. So that is what I have done here. It's not a song of a movie. And principles of ladder logics, and we'll see developing level OT. Then about CTAT. The CTAT is nothing but the Center of Excellence in Training and Research in Automation Technology. So yes, this is the question. What is automation? Where it is used? What are the there is no manual intervention. I can say that system is called semi-automated. So this is not a day-to-day life. We have come across a lot of home appliances, like the washing machine is one of the basic example, where you find both type of machine, like semi-automated and fully automated. So this is not a new term, but when you go for industry, that is completely different technology. See, in home appliance, we use embedded systems where that is used for home automation. Whereas in industry, yes, we need to go for some other technology called PLCs and other things, which is used for as a controller for industry automation. So where it is used, yes, it is used anywhere. Particularly when we talk about industry automation, it is used for industries. And what are the techniques involved? Yes, we'll see what are the techniques involved in that, and why we go for automation. Yes, we have a lot of advantages when we go for automation that we'll see in detail. So as I told you earlier, mainly we are trying to reduce the manpower. Everything is done by machine and already programmed. So that is what called automation. The advantage of automation is actually this is purely about the industry automation. So I am just talking in terms of productivity. So increased throughput, then improved quality or increased predictability of quality. So when we go for automation, when we rely on robots, then we can say that input robustness. That when we rely on robots, can this is possible with automation.
Hello, sir. Are you there? Hello, Rakesh sir. Participants may please be patient. Technical issues will resolve within 2 minutes. Thank you.
Am I clear? Whether my voice is audible?
It's audible, sir.
Thank you. Sorry for the interruption. I got some network issues here. So we'll continue with the presentation. Yes, we were talking about automation tools. So there are various types of tools used for automation, like ANN, artificial neural networks. DCS stands for distributed control systems. HMI stands for human machine interface. SCADA, this is the most popular term that most of us will come across when we learn about automation technology, supervisory control and data acquisition system. And PLC, program logic controller. PAC stands for programmable automation controller. Apart from that, we have some instrumentations, motion controls, and robotics. So reasons for automation. The main reason is we face the shortage of labor nowadays. Though we have good infrastructure in industry, the big challenge for running the industry is all about shortage in labor. We have a very great shortage of labor, and that is the reason why most of the North Indians used to come South India for working in industry. Particularly when we talk about production industry, we see a lot of people coming from North India to South India, mainly to work in production sectors. So next one is, okay, we have labors, but another important issue is high cost of labor. So that is another important thing. When we invest more amount for labor cost, then the production cost will be increased. So when we say production cost is increased, then the cost of the unit product also increases, and that will always lead to a big challenge in global market. So we should upgrade towards technology in order to compete in the global market. So next one is increased productivity and competition. So these are common things that we can easily understand when we talk about automation technology. So these are the things why we go for automation. Then safety, then reducing manufacturing lead time. Manufacturing lead time is nothing but the time taken for converting your raw material into finished product. Okay, so if you have automation technology in your process, entire time taken will be reduced. Then low cost in the long run. So this is the various reasons why we always think about automation technology, particularly when we talk about the industry. So as I told you, this is a broad classification of automation technology based on application. There are two types of classifications, like home automation and industry automation. So in case of home automation, yes, we have microprocessor, microcontroller, and ASICs, basically in embedded systems. Whereas when we go for industry automation, where we have PLCs, nothing but program logic controller, then PAC, then HMI, SCADA, and VFD. VFD stands for variable frequency drive. Yeah, now it's time for me to tell a good story as just a case study. Okay, I'm just going to share you a case study. This case study is shared just to make you understand what are the 4 different platforms of automation technology in general. Okay, so let me consider that you're walking on a road. you are walking on a road and there is some block across the road. ஒரு ரோட்ல நடந்து போயிட்டு இருக்கீங்க, மரம் சாஞ்சிருக்குன்னு வச்சுக்கோம். You are supposed to cross over the block. அந்த மரத்தை தாண்டி போகணும். Okay, this is the task given to you. And can anyone tell me what could be the first step in this process? The algorithm சொல்லுவோம் இல்லையா, algorithm step 1, step 2, step 3 எழுதுவோம் இல்லையா, இதுல first step என்னவா இருக்கும்? Any one of you? This is a interactive session. Nothing here, nothing right and wrong here. Students, feel free to interact. Just imagine that you are walking on a road. Roadல இருந்து போயிட்டு இருக்கீங்க, ஒரு மரம் சாஞ்சிருக்கு, இந்த மரத்தை தாண்டி போகணுங்கிற ஒரு டாஸ்க் உங்க கையில கொடுத்துருக்கேன். இதுல ஸ்டெப் 1 என்னவா இருக்கும்?
Initialization.
Exactly. Yes. Who is this?
Yeah, this is Madan Kumar.
Very good. You have to visualize, right? This is the first time I'm getting the first answer as the correct answer. Whenever I ask this question to the students, they give a lot of answers like looking for alternative path or going for some other's help. That is all correct. That is comes under later, step 2, step 3. But the first step is visualization. You have to visualize. Leah, you need to, your eyes are being used to visualize the block. So that starts the step 1. Then comes step 2. Step 2 என்னவா இருக்கும்? Okay, your eyes are used for visualization. பார்த்துருச்சு. Then what happens is, biologically I can say a signal from eyes pass to your brain. இல்லையா, உங்க brain போகும், ஒரு சிக்னல் போகும். அந்த சிக்னல் போயிட்டு brain தான் என்ன பண்ணுது? That is the place where the exact decision is being taken.
Next thing is size of the tree.
Tree? Any idea?
The size of the tree.
Okay, your brain has taken some decision.
Yes, that size of the tree. Whether we have to, it is a single stump or it is a big one, like that we have to visualize them. Then only we have to identify whether we have to move it or we need some other help like that.
Now.
Yes.
The tree.
Okay.
Brain on the decision எடுத்தாச்சு. Execution இல்லையா? The execution. Brain on the decision தான் முடியும். Execute பண்ண முடியாது. So for execution you have some driving unit. உங்க கையில
I didn't get it.
Or whatever you are going to walk or something. அது வந்து உங்க கையில யூஸ் பண்ணி.
I didn't get it.
Yeah.
I didn't get it.
You're right, exactly.
What do you say? Yes, sir. Yes.
You didn't get. Okay. And other things. அதெல்லாம் decision வந்து எடுத்துரும். Natural intelligence, so that we can take own. We can come to a conclusion. Okay, this can be done. அப்படின்னு ஒரு முடிவு எடுத்துரும். முடிவு எடுத்தா மட்டும் பத்தாது இல்லையா, செயல்படுத்தணும். We need to go for execution. Execution பண்றதுக்கு என்ன இருக்கு நமக்கு? We have skeletal and muscular system of body to execute the operation, action. The actionங்கிறது செய்யறதுக்கு கையும் காலும் தேவை இல்லையா?
Yeah. Yes.
இதுக்கப்புறம் சிக்னல் பிரெயினுக்கு போகுது. பிரெயின் வந்து என்ன பண்ணுது? ஒரு முடிவு எடுக்குது. முடிவு எடுத்துட்டு that has to be executed இல்லையா? So executionக்கு வந்து we should have some driving unit. அதான் நான் சொல்ல வரேன். Is it clear, sir?
Yeah. Oh, yeah.
Am I clear now?
I clear it now, sir. It's okay. Okay. Thanks, sir.
Fine, sir. Fine, sir. Thank you. So, just imagine now you are going to be replaced with a robot. In the இடத்துல வந்து the case study la I'm just going to place a humanoid robot, maybe chitti னு வெச்சுக்கோங்க. சிட்டியை வந்து நான் replace பண்றேன். இப்போ சிட்டிக்கு என்னென்னலாம் தேவைப்படும்? What are the things required for chitti to do the operation? So மனுஷனா இருக்கும்போது நமக்கு இதெல்லாம் நம்ம செயல்படுத்துறதுக்கு ஒரு sequence of operations சொன்னீங்க இல்லையா? Starting from visualize to action. So இந்த இடத்துல சிட்டி வந்து அந்த இடத்துல வைக்கிறீங்க. சிட்டிக்கு என்னெல்லாம் தேவைப்படும்? What could be the requirement for chitti to do the action of its own? Anybody please? நமக்கு கண்ணு இருக்கு பாக்குறதுக்கு, சிட்டிக்கு என்ன வேணும்? Or a robo, humanoid robo னு வெச்சுக்கோங்க. சிட்டிஸ் வேணா கன்ஃபியூஸ் பண்ற மாதிரி இருக்கும். Okay, it's a humanoid robo. ஒரு ஹியூமன் பீயிங் மாதிரி ஒரு ரோபோ வைக்கிறீங்க அங்க. அந்த ரோபோக்கு என்னெல்லாம் தேவைப்படும் இந்த ஆக்ஷன் செய்யறதுக்கு? You have eyes to see. Yeah, instead of eyes you should have some cameras or sensors. In general, like call it as sensors. So sensor is nothing but an input device. வெளியில நடக்கக்கூடிய பிசிக்கல் என்வரான்மெண்ட்ல நடக்கக்கூடிய சேஞ்சஸ் வந்து ரியலைஸ் பண்ணி அனலைஸ் பண்ணி அதை வந்து ரீட் பண்றதுக்கு ஒரு டிவைஸ் தேவை, ஒரு சுவிட்ச் தேவை. அதுதான் சென்சார். So sensor is nothing but a switch. It can either be in one state or zero state based on the physical environment. Okay. So your sensors are fixed now for GT. Okay, fine. Next thing is brain. We have brain for natural taking decision, natural intelligence irukku. But for machine, for robo, enna venum? We should have a controller. Yeah, we should have a controller. That controller is compared to be PLC here. So I will show you this picture, which makes you to clearly understand about the case study. So I was comparing this eyes with the sensor. Yeah, you see, your person is there whose eyes is being compared for sensing, and his brain is being compared with the controller. See, brain for decision making. We have controller here. This controller is nothing but PLC, and yes, that is since when we talk about brain, we have natural intelligence, but when we talk about controller, we should have artificial intelligence. That's AI that comes into picture. Okay. So in the AA, இதெல்லாம் வந்து அதோட பேசிக் ஃபண்ட் என்ன கேட்டீங்கன்னா PLC, ப்ரோக்ராம் லாஜிக் கண்ட்ரோலர். We do logical diagrams, we draw the diagrams, logical circuits diagrams வரையும் லேடர் லாஜிக் பேரு. அதை வரைஞ்சு என்ன பண்ணுவோம்னா we just embed that diagram to the chipல வந்து embed பண்ணிடுவோம். So the chip can be acting as a brain for the machine. Okay, so that is the concept. And now the third thing, important thing is actuation, which is nothing but driving unit. So for human being, we have muscles, skeletal and muscular systems for doing the action. But for we can call it, it's being changed, but system. Okay. Yeah. So it's being linked to actuator with the help of DAC. DAC is nothing but digital to analog converter, and we take the actuator will does the process, and a part of the feedback is taken from the process, and that is being taken through sensors. And this sensor signal is converted to ADC, analog to digital converter, and that goes to controller. So this is a kind of a closed loop system. Okay, that's all about automation technology. Is it clear? So let me get into the platform right now. So this is the first one, hydraulics. So hydraulics, pneumatics, PLCs, and sensors. All these four platforms will make you to be an automation engineer. Okay, so if you really want to tell yourself as an automation engineer, you should be well versed in hydraulics, pneumatics, PLCs, and sensorics. So what is hydraulics? Hydraulics actually is kind of machinery you might have seen in the roadside environment. Hydraulic machines are machineries and tools that uses liquid fluid power to do simple work. That is, machinery is operated by use of hydraulics, where a liquid is a powering medium. Okay, so we use oil. Oil is stored in the tank, and this oil is being pumped up with the motor. So this oil will flow through the hose. This is a kind of closed loop system. So it pushes the cylinders so that it moves forward and backward. You can easily understand when I show the video. So let me go to the presentation right now. So next one is pneumatic system. Here the only difference between hydraulic and pneumatic is, see, in hydraulic case, whenever you feel that you have to deal with the weight more than 50 kg, you have to go for hydraulic system. Say for example, shipbuilding industry எடுத்துக்கோங்க. கப்பலை வந்து தயாரிக்கிறது நிலத்துல தான், ஆனா கப்பலை தள்ளி போய் கடல்ல இறக்கணும் இல்லையா? சோ தள்ளுறது வந்து நாட் ஈஸி, இட்ஸ் நாட் ஈஸி டாஸ்க், இட்ஸ் நாட் கேன் புஷ் பண்ணி இறக்கணும்னா என்ன பண்ணணும்? ஹைட்ராலிக் சிஸ்டம் யூஸ் பண்ணுவாங்க. ஸோ whenever you feel that we are going to deal with heavy weight, அப்பதான் அந்த இடத்துல ஹைட்ராலிக் சிஸ்டம் தான் யூஸ் பண்ணுவாங்க. இப்போ ரீசெண்டா மதுரையில கூட பிரிட்ஜ் இருந்துச்சு இல்லையா? அங்க வந்து என்ன ஃபெயிலியர் கேட்டீங்கன்னா ஹைட்ராலிக் சிஸ்டம் தான் ஃபெயிலியர் ஆயிருக்கு. ஓகே, ஸோ இதுதான் வந்து எங்கெல்லாம் உங்களுக்கு வந்து ஹெவி வெயிட்டோட நீங்க டீல் பண்றீங்களோ அங்கெல்லாம் ஹைட்ராலிக் சிஸ்டம் போவீங்க. And whenever you feel the weight, we are going to deal with the weight less than 50 kg, then you can go for. There is no need for going for hydraulic system, because in hydraulic there is a big disadvantage. There will be chances for leakage of oil. So say for example, food industry la poi neenga automation pannuveenga. So in case of food industry, the best driving unit is pneumatic system. Ena hydraulic system use பண்ணும்போது என்ன ஆகும்? The leakage of oil may be considered as a toxic, இல்லையா? So அதே மாதிரி pharmaceutical industry ல pneumatic system யூஸ் பண்ணலாம். Okay, So this is what the application of pneumatic system all about. And pneumatic systems are power systems used using compressed air as a working medium for the power transmission. So you are going to have compressor here, and instead of oil, you are going to compress the air, and rest of the things are same. You are going to have cylinders for linear action. You're going to have rotors for rotary action. அதெல்லாம் வந்து சேம் தான், பட் the size of the equipment changes. In case of hydraulic, you have big equipment, whereas in case and comes the PLC. This is the third important platform. So I can say that it is nothing but a digital computer used for automation of electromechanical processes, such as control of machineries on factory assembly lines. And PLC, the input-output behavior is similar to that of electromagnetic relay or pneumatic switching valve controller. The program is stored in an electronic memory. So when you talk about switches, actually I can say that if you look at industry, the revolution of industry, earlier we were using mechanical switches, gears and pulleys that use pannittom. So actually that is very hectic. Human being has to be dedicatedly working on operating the rotating logic. Electromechanical switch வந்து என்ன ஒரு compared to electronic switch. So அதுல என்ன ஒரு drawback கேட்டீங்கன்னா, you have lot of wires hanging there. If anything goes wrong, it's not so easy for you to diagnostic problem. So you want to really troubleshoot it, and you have to shut off the entire process. That is nothing but you are going to switch off the production line. So industry ஏதாவது ப்ராப்ளம்னா industry ரன் பண்ண முடியாது. ரன் பண்ண switch off பண்ணிட்டீங்கன்னா க்ளோஸ் பண்ணிடணும் அர்த்தம். அதுக்கப்புறம் ப்ராப்ளம் ரெக்டிஃபை பண்ணுறதுக்கு ஓப்பன் பண்ணும். ஸோ அப்படி பண்ணும்போது என்ன ஆகும்னா ப்ரொடக்ஷன் பாதிக்கப்படும் இல்லையா? ஸோ தட் இஸ் த then came the electronic switch. The electronic switch is something called PLC. So என்ன பண்ணாங்கன்னா the relay logic வந்து அழகா மாத்திட்டாங்க. They converted the entire physical wiring system into the virtual wiring system, and that is what called PLC. So PLC ல என்ன பண்ணுவாங்கன்னா, nothing but we are going to draw the ladder logic circuit. Ladder தான் என்ன மீனிங்னா, it's nothing but ladder is ஏணி இல்லையா, தமிழ்ல ஏணி சொல்லுவாங்க. So பார்க்கிறதுக்கு ஈவா இருக்கும். The logic circuit seems to be like a ஏணி, so that's why it is ladder logic. And the advantage of this logic is it's not so complicated as compared to the C programming. C programming में complication கிடையாது. So C almost எல்லாம் படிச்சிருப்போம் இல்லையா? Cங்கிறது it's a really tough language for me. Sorry, my voice is breaking. Okay, am I clear now?
Yes, sir. But
am I clear now?
Sometimes.
Fine. Okay. I think there is some network issue. Okay, anyhow, let me go slowly. Fine, thank you. So, in case of ladder logic, what we do is we draw the logical circuits, and this diagram will be embedded on the chip, and that chip will act as a brain for the machine. That's the thing that we discussed so far. And the next thing is sensor. So this, of course, the fourth important topic, but the most important thing for automation, because as I told you, the case study, the entire process started with the sensor. Visualization. So we need to have a right sensor for right application. So the sensor is nothing but an input device which is used to read the environment and pass the signal to the controller. And where we have the logical circuits written in the controller, and this controller will lead to the driving unit based on the signals received from sensor. Okay, so sensor it's a big ocean. But here we deal with the 5 important sensors like industry sensors. The inductive sensor, capacitive sensor, photoelectric sensor, magnetic sensor. அந்த மாதிரி ஒரு முக்கியமான 5 சென்சார் இருக்கு. அந்த 5 சென்சார் தான் என்ன பண்ணுவோம்னா, we have that real time application of the sensor. We do experience with that. So this is the introduction about sensor. Sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. Okay, so once the physical parameters has been converted to an electrical equivalent, it is easily input into a computer or microprocessor for manipulating, analyzing, and displaying. So the reason why we convert that signal into a digital signal is because we are going to do some manipulation based on the signal received from the sensor. So we can easily connect it to the digital computer. Okay. So I can broadly classify the sensor based on the application. That is nothing but contact sensor and non-contact sensor. Contact sensor, as the name says, a sensor that requires physical contact with the stimulus. Example, strain gauge, most temperature sensor, example for contact sensors. I'm not talking about the IR sensor, that is different, but the old thermometer, which we have body contact to measure the temperature of the body. So that is an example for contact sensor. Coming to non-contact sensor, it doesn't require any kind of physical contact. Example, most optical and magnetic sensors. Infrared thermometers is the best example. Today we talk about corona, COVID situation, pandemic situation. Wherever you go, you find the person at the entrance having this infrared thermometer to measure your body temperature. Okay, that's an example for non-contact sensor. And other classification based on the broad area of detection. So we have electrical sensors, magnetic sensors, electromagnetic sensors. Acoustic sensors are used for sound detection. Chemical sensors, optical sensors, heat, that is nothing but temperature sensor. Then comes mechanical, radiation, biological, etc. Okay, so based on the area which we use or area for detection, we can classify the sensors. So this diagram just shows you the various types of sensors in general. Okay, now coming to the application point, application of automation technology. See, in industry, wherever you go today, you will come across automation everywhere, starting from the purchase of raw material to the delivery of product to the market. You will find automation everywhere across the department. Application of automation. Here, this diagram shows a conveyor belt. Tin is being moved in the conveyor belt. And we have sensor just to sense whether the thing is being actually covered or not. Okay, so this is being automatically monitored. There is no person here standing here to monitor it. So this category, this is when the tin is actually closed, then it is considered to be fine good. And if the tin is not closed, then it is considered to be defective good. So the defective good should be identified and which has to be removed from the production line. Okay, so that is the aim of this setup. So that is how the entire setup function. Okay. So if you find here, you can see there are two sensors, right? This is one sensor and this is other sensor. So this sensor actually used for sensing whether the tin has been actually closed or not. Okay. But this is the sensor which shows whether the tin has reached the particular point or not. Okay. So every time when the tin keeps on moving in the conveyor belt, this sensor is used to count the of course, this output of the sensor will be lead to a counter. So that is used for count the number of tins which has been crossed over the toll gate. Okay, is it clear? So this is the application of automation in the industry. One of the application, and this is another application. See, you have PLC here, and you have an industrial robot, and this robot is used for welding purpose. This is used in automation in the car industry. We are welding the car door actually. So we have conveyor belt here that is also moving, and this is being connected to the PLC. So PLC, which will have the logical diagram, will control over the movement of the conveyor belt based on it gives the input like a timer for the functionality. It also gives the input like how long the how fast the conveyor belt should move and how long it can be in the stationary position. Okay, now coming to PLC, glimpses of PLC. Actually, this is the PLC kit seeing on the screen is the actual PLC which is being used here. It is being supplied from the company called Bosch. Bosch has his own authorized software called Indra Logic. So what we do is we train the students to we'll train them on scratch, starting from scratch. We'll tell them how to construct a ladder diagram for basic logic circuits. Say, for example, AND gate, OR gate, NOR gate, clear. Truth table. So we'll tell you how to construct a ladder circuit for satisfying the truth table of these logics. So that is the first exercise for any students, and the maximum knowledge that you should have to learn these languages. You should know the PowerPoint, Paint, how to operate with the toolbars in the Paint. So that is enough, more than enough. So I hope most of us will know PowerPoint, Paint, open money, icon, click பண்ணி drag பண்ணி படம் வரைய தெரியும் இல்லையா? So that is the maximum knowledge required for you to really learn this language. C language கஷ்டமான language கிடையாது. It's not so tough language as considered to be C, because C நான் ஏற்கனவே சொன்ன மாதிரி C ல வந்து ரெண்டு இன்புட் வாங்கி அவுட்புட் கொடுக்கணும். Say for example A plus B equal to C அப்படின்னு ஒரு ப்ரோக்ராம் எழுதணும்னா I should have at least a maximum line of 10 lines of code இல்லையா? Minimum starting from header file அதுல நான் வந்து கோட் எழுதணும்னு ஒரு ரெண்டு இன்புட் வாங்கி அவுட்புட் கொடுக்கிறதுக்கு மினிமம் 10 lines of code இருக்கணும். But in case of PLC that is not required. See, just imagine ஒரு ரெண்டு இன்புட் வாங்கி அவுட்புட் கொடுக்கிறதுக்கு 10 லைன் ஆஃப் கோடுனா இண்டஸ்ட்ரியில எவ்வளவு மிஷினரிஸ் இருக்கும், அந்த மிஷின்ஸ்ல எவ்வளவு ஆபரேஷன்ஸ் இருக்கும், அந்த ஆபரேஷன்ஸ்க்கு நம்ம C கோட் எழுதணும்னா எழுதிடலாம். பட் if anything goes wrong, then it's not so easy for you to debug it. So people all over the world, they came to a conclusion that C cannot be used for industry application. Industry application ku C language வந்து யூஸ் பண்ண முடியாது. So they need to come up for a common language, and that language was called as ladder language. Okay. So PLC, yes, though another important thing is, though you study the PLC in a Bosch company, the same circuit is applicable for Siemens. Okay, Siemens and Bosch, those are the two companies and considered to be giant in automation technology. அதுக்கப்புறம் அடுத்தது பார்த்தீங்கன்னா we have a lot of companies like Honeywell, Rockwell, இந்த மாதிரி நிறைய ABB, இந்த மாதிரி நிறைய கம்பெனிஸ் இருக்காங்க. பட் எல்லா கம்பெனியும் பொதுவாக என்ன இருக்கக்கூடிய விஷயம் என்ன கேட்டீங்கன்னா லேடர் லாஜிக். The ladder logic is common for any company, and that is the reason why we encourage the students to learn this language. Because tomorrow, if you want to be really considered to be an industry ready person, நீங்க இண்டஸ்ட்ரியில போய் ஒர்க் பண்ணணும் ஆசைப்படுறீங்க, இண்டஸ்ட்ரியில போய் ஒரு எனி இண்டஸ்ட்ரி யூ டேக், if you want to work in a company as an automation engineer, you should know this language. So in the language be able to understand it. So PLC, now actually PLC was it was developed for the same function relay logic. Programmable. The advantage of PLC is actually it's very programmable, reusable, and reliable. Okay. So see, I can easily tell you an example. வீட்ல வாஷிங் மிஷின்ல ஏதாவது ப்ராப்ளம் வச்சுக்கோங்களேன், what the you immediately call the service engineer, right? Service engineer வருவாங்க, வந்து என்ன பண்ணுவாங்க, though there is a minor correction or minor problem with the board, what they do is they will replace the entire board. உங்கள்கிட்ட வந்து என்ன பண்ணிடுவாங்க, அதுக்கு சார்ஜ் பண்ணிடுவாங்க. They will not go and debug the code. அந்த கோட் எல்லாம் டீபக் பண்ண மாட்டாங்க, அங்க இருக்க எரர் எல்லாம் வந்து ரெக்டிஃபை பண்ண மாட்டாங்க. They simply replace the board. இந்த போர்டை மாத்தி விட்டு போயிடுவாங்க. பட் இன் கேஸ் ஆஃப் பிஎல்சி பொறுத்த வரைக்கும் அப்படி கிடையாது. நீங்க ஒரு ப்ரோக்ராம் ஒரு பிஎல்சில ரைட் பண்ணீங்கன்னா அதே பிஎல்சில திரும்ப நீங்க என்ன பண்ணலாம், யூ கேன் ரீரைட் தி கோட். சம்திங் லைக் பென்ட்ரைவ்ல நீங்க பண்றீங்க இல்லையா, பென்ட்ரைவ் வந்து எப்படி நீங்க எத்தனை ஃபைல்ஸ் வேணா ஸ்டோர் பண்றீங்களோ ஃபைல்ஸை டெலிட் பண்ணலாம், ஃபைல்ஸ் வந்து ரீகாப்பி பண்ணிக்கலாம். ஸோ இதெல்லாம் வந்து சாத்தியமோ அதே மாதிரி தான் பிஎல்சிலையும் நீங்க என்ன பண்ணலாம், யூ கேன் ஜஸ்ட் ட்ரீட் இட் அஸ் லைக் எ பென்ட்ரைவ். ஓகே, ஸோ தட் இஸ் அன் அட்வான்டேஜ். யூ நீட் நாட் கோ ஃபார் நியூ, simply rewrite the code and you can apply for some other application. That's why it is called as reusable, and also the reliability is 100%. I can say 100% because it doesn't have any kind of noise intervention. See, in embedded systems, the drawback is you have it's prone to noise. See, in நீங்க ஒரு embedded system board பாத்திருக்கீங்க இல்லையா, PCB board. A PCB board is made of printed circuit board பாத்திருப்பீங்க இல்லையா, அது வந்து that is not applicable for industry application because the industry environment is totally different when compared to the home environment. You have a noise there, you have radiation there. So this kind of things may affect the functionality of the electronic circuits. So in case of PLC, that is not possible. It's highly reliable. You have control room separately, you have controller there, and that is being connected to the machine separately. So your system is highly reliable, I could say. So this is the architecture of PLC, very similar to the ordinary computer. You have CPU called as central processing unit, and you have memory unit. You have program here. The program is a program, and that program is being written to the memory, and memory is being connected to CPU through address bus and data bus, and you have a controller bus also. And these are the outlet part. So here it is being used for interacting with the real world. So I told you sensors, yeah, the sensors will act as an input device, so it reads the parameter from real world, and the output is nothing but the driver. Driver is both the hydraulic drive, pneumatic drive, and electric motor drive. So that is the drive unit actuators which deals with the real world. So next one is, we are getting much deeper into the architecture. We have a central processing unit which is being connected to power supply. Then we have I/O module. This input sensing devices are being used for I/O module. As I told you, sensors are nothing but switch. Okay, this is nothing but switch. So this is NO switch and NC switch. NO stands for normally open and NC stands for normally closed. So you have a combination of the switches here, which is nothing but sensor that is being connected to the CPU. That is called controller, and the output is being connected to the output module. Okay, fine. But here you have something called programming devices. The programming devices in the laptop. Most probably we'll use the laptop for installing the software, IndraLogic software. So IndraLogic software is a platform where we write the ladder logic circuit. And this ladder logic circuit is further returned to the memory here at the CPU. Okay. So this is a slide just to make you understand the difference between PLC and PC. There is no much big difference. As I told you, PC are the computers used for home environment, where PLC is the industrial computer which is used for industrial environment. And you will never find any kind of keyboards and CD drives, monitors, disk drives in the case of PLC. And also you have communication ports and terminals for input and output devices in case of PLC. So this is the actual PLC kit. So this black color slot represents the power slot, and the one which is next to that of black color, you can find two blue color slot and two rose color slot. So the blue color actually stands for onboard digital inputs, and rose color stands for onboard digital output. So and just more. So boot process அதே மாதிரி booting process நடக்கும். Booting process நடந்து random display காமிச்சாதான் it's an indication for you to understand that the computer is in a normal mode. Okay. Okay, fine. Now, Internet of Things. Actually, the IoT is a big topic which cannot be covered in a single day. I'm just trying to give you some glimpses of IoT. Definition says that it's also called as the IoT, Internet of Objects, refer to a wireless network between objects. Usually, the network will be wireless and self-configuring, such as household appliances. And another definition is by embedding short-range mobile transceivers into a wide area of additional gadgets and everyday items, enabling a new form of communication between people and things, and between things themselves. So nowadays we have a smartphone in our hand, right? So simply I can explain you IoT by means of this example. See, industry நடக்கக்கூடிய automation வந்து நீங்க ஒரு say for example, I am the boss of the company and my company is in Chennai. But I am there in US. So if I want to monitor my entire company process, what's happening in industry, so I can simply log into my mobile and I can get the data from the cloud. So நீங்க இண்டஸ்ட்ரியில் நடக்கக்கூடிய ஆட்டோமேஷன் வந்து கிளவுடோட லிங்க் பண்ணிட்டீங்கன்னா கிளவுட்ல இருந்து டேட்டாஸ் வந்து நீங்க ரிசீவ் பண்றீங்க. You are easily able to watch, monitor the data or collect the data or supervise the data from remote area. And this is what called best example for IoT. Okay. So whenever you feel that your automation is linked with the cloud system, and when you are able to access the data through cloud system, then that is called IoT, Internet of Things. Okay. So you are just mapping internet with the things. Okay. So this is a best example. It's an architecture of industry IoT. See, as I told you, you have smartphones in your hand, and this is the public cloud data. And you have the initial level of data, which is nothing but first level of edging process and second level of edging process, which is our data received from the industry. This you can see PLC here, yeah, PLC pakringa. The PLC data எல்லாத்தையும் வாங்கி further process பண்றதுக்கு cloud மூலமா நம்ம link பண்ணினோம்னா that is called industrial IoT. Okay. And when we talk about industry 4.0, industry IoT is a part of it. Sorry. When we talk about industry 4.0, industry IoT is a part of it. We have network centric. It should be industrial apps. We should have quality. You should have safety. We should have automation technology. You should have monitoring tools. Then you should have sensors. It should be wireless sensor, and everything is leads you towards Industry 4.0. And today it's a hot cake. We talk about Industry 4.0 everywhere. People are talking about it. Industry has a great revolution now. We started thinking about how to link this latest industrial, how to upgrade industries towards Industry 4.0. Okay. Now let me get you into this CTAT center. So this is the Center of Excellence in Training and Research in Automation Technology. Actually, we are proud to say that we had a late His Excellency Dr. APJ Abdul Kalam sir, the former Vice President of India, who inaugurated the center during Aerospace Festival in 2013. Along with him, we have our Chancellor Dr. K. Veeramani, and apart from that, we have Dr. Sivadanam Pillai, who was the CEO of BrahMos, then Peter Gosses is the director, and Mr. Rajkumar, the Vice President of Bosch Rexroth. Then comes various scientists, USL Consulate from DRDO, and Professor Mr. Dr. Jagadish from ISC Bangalore. So these are the eminent persons who were there with us for inauguration. And the main objective of this center is to bridge the gap basically in automation technology. We are trying to make use of this technology to reach the rural areas. Okay, we are trying to bridge the gap, and we also encourage the students to pursue post-graduation and doctoral programs with the help of this facility. So as I told you, we have 4 different labs: hydraulics, pneumatics, PLC, and sensorics. Because in that case study itself, it is very clear, right? If you want to really claim to you as an automation engineer, you have to come across. And these are the various facilities available with us. We have a workstation. We have IntelliLogic software. This is not an open source software. It's a authorized licensed software from Bosch. And we have an assembling board for sensors, and we also have sample material kits. Because in sensors, what we do is we study the characteristics of sensor with respect to the material, which will make you to understand which type of sensor can be used for which application. Okay, that gives the students a clear idea about using engineering. Not only in engineering, even for polytechnic students, you are expert in doing projects. So whenever you go for projects, you will come across all these sensors. You cannot do a project without a sensor. So this type of sensors, when you go and use it, so for that you should study the function characteristics of sensor with respect to the material. And this is the snapshot. What you see is hydraulic lab. Students are working on it. So this is what I was talking about. See, you have a kind of a reservoir, oil tank. This oil tank has been, above the oil tank you have the motor. So the motor is used for pumping the oil, and can you find this black color hose? This black color hose is used for fuel passage. It's nothing but the oil passes through this, and you have cylinders for inlet and outlet. Okay, that is being connected to the black color hose. See, generally, if you want to do any action in the physical environment, there are 2 type of action. One is called linear action, the other one is called rotary action. For linear action, what we do is we rely on cylinders. For rotary action, we rely on motors. Okay, whether it's going to be electrical motor or pneumatic motor or hydraulic motor, whatever it will be. But if you want to have a kind of rotary action, you have to go for motors. And for linear action, you have to go for cylinders. And this is the pneumatic lab. As I told you, it's not a big. There is no big difference between hydraulics and pneumatics. The only difference is the oil. Here you use compressed air, there you use oil, and the miniature of size. You won't find bulky cylinders here. You find everything very small, in very small size. And then comes PLC. PLC, as I told you, is the controller. This is considered to be a brain for the machine. So, see, can you see people working on a laptop? So here we have IntelliLogic software installed in the laptop, and the students will write the code, and that code will be transferred to this PLC kit through the Ethernet cable. So in the PLC kit, we have a memory chip. So in that memory chip, the code will be written, and students can really have a fun of knowing whether the logic that they have written satisfy the application or not. Okay, so what we do is we usually give the application and we'll ask the students to write the code for it. And the students should come with the innovative code so that they can write it and test it, because they can easily simulate it and they can have enjoyment in knowing whether the code actually functions with respect to the application or not. And then comes the sensor lab. As I told you, sensor is the most important thing that when we talk about automation, because this is the one which actually interacts with the environment. So you say, for example, if I want to have a home automation, if I'm going to fix a kind of temperature sensor in a room, if I want to automatically switch on and switch off the AC, what I had to do is I had to keep the temperature sensor. So how does it function? As it keep on, as the day progresses from the morning to afternoon, the temperature, room temperature slowly increases, right? So what happens is over target level, then the AC automatically gets switched on based on the input from the temperature sensor. And if the temperature of the room is getting low, then automatically what happens is the AC gets off. Okay, so this can be easily controlled with the help of a temperature sensor. So sensor is very important here. So I will just stop the presentation with this, and I will take you to the video for the next 10 minutes. I will just show you this lab here. So this is the hydraulic lab. So all these equipments are the real-time equipments which is being used in the industry. This is not a prototype. Whatever you see in the video are the real-time equipments. So we have 4 workstations here. So this is how the So now I'm just going to explain you a kind of a simple hydraulic circuit. See this hose. This black hose is actually transferring the oil, compressed oil. And see now I'm just operating this cylinder. This is called DCV, dash and control valve. So what I'm doing here is I have a jack here. This is a purely manual controller. It's pure hydraulics. We don't have any kind of electronic switch controlling this DCV. Whenever I push this jack, what happens is the cylinder, the piston inside the cylinder gets expanded. It moves forward, and when I release this jack, automatically it comes to the home position. Okay. So this is what I'm trying to show in the video. Hope you are able to see that. Can you notice this? So whenever I switch on, that moves in the forward direction, and when I release it, it comes to the home position. So this is an example for the linear action. Okay. So linear action. This kind of cylinders you can see in JCBs. Roadside JCBs லாம் பார்த்திருப்பீங்க இல்லையா? So அதில் பார்த்திருப்பீங்க. This kind of cylinders you can see there. And this is another video just to show you an example for electro hydraulics. So can you see this? We have DCVs here, but the DCV is considered to be solenoid control DCV. Whenever I say solenoid, it's nothing but relay logic controller. So you have relay logic circuits, wires. So these are the wires hanging here is the relay logic wires. நான் சொன்னேன் இல்லையா relay logic wires வந்து பாத்தீங்கன்னா wire தொங்கிட்டு இருக்கும் சொன்னாங்க. It's a physical wire. இதுல வந்து drawback ஆயிட்டீங்கன்னா there is a small loose contact, then the entire system has to be debugged. It's not so easy for debug. You have to come start from scratch. So அதனால தான் என்ன பண்ணாங்கன்னா this kind of physical wiring system was replaced with the electronic wiring system. That is nothing but PLC. Okay, where you never find any kind of physical wiring. Everything is considered to be virtual wiring. So that is all about hydraulics. Next, I will take you to pneumatics lab. So for pneumatics lab, we have 2 workstations. So we start with the compressor. So in case of hydraulic, we used oil, yeah, but in case of pneumatic, we use air. So air is very freely available in the environment. So this compressor sucks the air and it compresses the air. There is no cost for fuel, and we are passing that air to through this hose, black color hose. That's why I told you everything is similar when compared to the hydraulics, but the only thing is the size of the equipment. Hydraulic பெரிய cylinders பார்த்தீங்க, but இங்க pneumatics சின்ன cylinders. The size has been reduced here, and even the hose பார்க்குறீங்களா, black color hose, இங்க வந்து சின்ன வயரா இருக்கும். So that will be helping you to pass the air, compressed air. So this is an example for electro-pneumatics. The video that you are going to see will explain you electro-pneumatics. So pneumatic is verum cylinders and pneumatics சொல்லுவாங்க. But when you have this kind of linkage between the electrical switches and pneumatic cylinders, that is called electro-pneumatics. So can you see this? This setup is nothing but the solenoid, and you have this wiring which is used for controlling the switch on and switch off of the solenoid. And this is nothing but DCV, direction control valve, which is being linked to the piston. Okay, so based on the on and off of this solenoid, the piston, the cylinder either moves in forward or reverse direction. And this entire wiring system will be replaced with virtual wiring or nothing but ladder logic in case of PLC. So coming to PLC now. So I told you we have laptops installed with see, every time when we start learning the code, it's not so easy for us to directly write the exact code for the application. So what we do is we start learning the code with the help of a simulator board. This board is called simulator board. We have nearly around 40 different applications here, and we train the students on different applications. So this simulator board will help you to test whether the code written by you is right or wrong. And this is the actual PLC kit. What you see here is the PLC kit. So this is the L20dB PLC, which is not a prototype, which is the actual PLC which is being used in industry. And this part is the trainer part. This part you can't find in industry. This is given just to test whether the code is right or wrong. You can simply make use of the Boolean switches here. This will help you to feed the input to the PLC. And also you can see the output of the PLC from the LEDs here. Okay. And also you can find analog and digital output that I will explain you later. Yes, this is another important kit in our lab. This is VFD, variable frequency drive. So VFD is mainly used for material handling systems. When I talk about conveyor belt, yes, we have VFD here. So you can control the speed of the motor with the help of frequency. And now what you see on the screen is the prototype of CNC. See, CNC, I know most of you come across this CNC in your syllabus, computer numeric control machine. But in order to learn the language, you can start with this prototype. Here you can see 4-axis motors. So we train the students on how to write the code for CNC machine. And we do have a vertical CNC machine with us, supplied from Bosch. And this is the PLC kit. So as I told you, this is similar to the computer. See, you can see a booting process. Boot 1, boot 2. Yes, this is the most important thing which I want to highlight. This is the chip, actual chip where the code is being written. Okay, this code is embedded in the chip, and this chip will be inserted here. Okay. and this code will be embedded in the chip, and it is being inserted here. So this is the PLC kit in the running mode. So here, as I told you, you have Boolean switches. I'm switching on the Boolean, and as I switch on, you can see here LED glowing on. Yeah. And this is the totally we have 16 Boolean switches, which can be used for coding. This is the analog switch, which is nothing but potentiometer. See, most of the physical environments signals that you read from physical environment will be considered to be a continuous signal or analog signal. So, if you really want to track this signal, you should have a proficiency of your PLC kit to process this signal. Okay. So, instead of going for ADC, I can directly trap the analog signal and feed it to the PLC. Okay. And also, I can get the output, analog output from the PLC directly. So I have the potentiometer and the analog meter here for that purpose. So what happens here is I'm just removing the black slot. So when I remove this black slot, you can see that the power gets off, right? Yeah, this is the power slot. So when I remove it, the entire power goes off. So that's all about PLC. Next thing is a sensor. So I hope the presentation ends up with this sensor part. So these are the various types of sensors like ultrasonic sensor, resistive type, capacitive type, inductive type. This is assembly board showing the circuit connection. So here I'm going to a photoelectric sensor. Here, the output box is just to show you to insert a barrier in between the transmitter and receiver. See, you can see transmitter and receiver separately. So whenever I insert, the LED goes off. Okay. So that is the indication for me to know whether my sensor works. And these are the different sample of materials. As I told you, if you really want to understand the sensor functionality, you have to test it with respect to the material. So this is the sample of material from Bosch, which will help you to understand how the sensor works and which type of sensor application. Okay. And finally, I will end up with a video showing a project which was done by our student. So this is automatic integrated filling and mixing of different heights of bottles used in PLC. See, this is a kit which was designed by our student. You have two tanks, tank 1 and tank 2, having different mixtures of proportions, materials. This happens in processing industry. Okay, so you find the conveyor belt here and consider this as a bottle. The bottle keeps on moving and it reaches to the particular point, say for example stage 1, we have sensors. So once it reaches stage 1, the tank 1 proportion will fill up the bottle for a certain duration. And when it reaches to a certain level, we have another sensor to sense it. Then it moves to the stage 2, where we have tank 2 proportion coming to the stage 2. And the bottle is being filled with the tank 2 proportion. Now, once it reaches certain level, then the conveyor belt moves on to the next phase. Okay, so the bottle keeps on moving to the next stage. So this is an example. See, can you see the sensors here? So these sensors are nothing but lower level sensors and upper level sensors that indicates the level of mixtures being filled up in the bottle. So lower level sensor says that yes, you have reached to the you are considered to be a fresh bottle. It has to be filled up to the next level. And upper level sensor indicates that it has reached the ultimate level. It can move to the next phase. Okay. And this electrical motor is responsible for moving the conveyor belt so that the bottle goes on to the next phase. So that's it. This is a sample video just to encourage you to know about automation technology. So with this, let me wind up the presentation with the sayings from the famous person Bill Gates. The first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. The second is that the automation applied to an inefficient operation will magnify the inefficiency. So thanks for your patience, and I will be happy to answer for your questions for next few minutes. Any questions?
Thank you so much, sir,
Thank you, ma'am.
for sharing your ideas about automation. Participants, any queries? Once again, I thank you to all for your kind cooperation, patient listening.
Thank you, ma'am. Thanks for giving this opportunity. I request you to kindly share the feedback later, ma'am. That will be helping me to mold further.
Okay, sir. Okay,
Thank,
sir. Thank you, sir.
thank you. Thank you so much.
Shall we end the session, sir?
Yes, ma'am. That's it from my end.
Okay. Okay. Sir. Participants, the feedback link will be sent in the chat box and also in WhatsApp group. Thank you.
Thank you. Thank you.
Okay, sir.